So in 2016, 1 year after GraphQL was publicly launched, Rod Johnson asked me to add if we can add GraphQL support to Neo4j. And looking at the GraphQL spec, it looked actually quite straightforward because after all you have an API schema, so where you describe entities and their relationships, and then you have queries which are tree queries. So I thought, oh, it should be too hard to actually take that and turn this into an Cypher query, right? And that means in 2016, so when was the first commit actually? It was like a long time ago. Commits. Oh, this new GitHub API is really interesting. Oh, there's commits. So I think the first commit was sometime October 16 or something like that. Let's see. November 16. Yeah, 25th of October 2016. So, and what I set out to build initially was an extension for Neo4j that you could just install into your database and which would offer a GraphQL API to Neo4j. And that worked quite well in general. We built this out, and you post it in GraphQL schema to the database, or it could even extract it from the database as well. And then whenever a GraphQL query came along, you could just transform this into a Cypher query and run it against the database, return the results, and then you're done. So basically, we built this extension, and then in, for instance, in Neo4j desktop, you had a one-click install for that. And bunch of other things that are added to kind of play around and experiment with. So there are also procedures who can run GraphQL queries and add a schema, and also have something like GraphQL schema that kind of renders that visually. So, but as time progressed, we were kind of getting more and more interest in GraphQL as a kind of proper middleware integration, and that's how GrandStack came along. So GrandStack is basically a combination of GraphQL, React, Apollo, and Neo4j, which is a middleware-based approach where you don't kind of deploy a plugin to your database, but you have a middleware that then can also have custom resolvers and so on. So we took the lessons learned from the database extensions and re-implemented this in JavaScript. So now you can use this in all the JavaScript stacks with Apollo server and or plain Express servers if you want to do that. So which is really nice. At the same time, we have a lot of users and customers who use Java middlewares, so like Spring Framework or Micronaut or Vertex or just plain Tomcat or Jetty or something like that, or even JE application servers. So we thought, okay, here we have the JavaScript implementation, but can't we take also what we have in the plugin and extract it somehow into a pure Java library? And that's what we did with Neo4j GraphQL Java. Which is a pure translator library. So it's a Java library, it's a pure translator, and it takes the GraphQL schema and then generates an enhanced augmented schema for that has additionally mutations and queries, and that allows you to then run these GraphQL queries, and we translate this into Cypher, and you can then run this into a database. So here's an example on using this from Kotlin. So you have a schema, you build a schema object, and then you take the schema object and translate the GraphQL query, in this case this one, into a Cypher query, and you also get the params. So we also extract all the literal values into proper Cypher parameters. And then basically you get as part of this result a Cypher statement which uses pattern comprehensions currently and map projections for doing the nesting. And it only returns really the data that you want, right? So if you say I only want to have the age of this person returned, then it only extracts the age property here. Okay, and it has a lot of features, supports almost a large part of the GraphQL spec. Subscriptions, for instance, are not yet there. But what we did is we created a kind of TCK, which means these are ASCII files, which have basically a schema, and then GraphQL queries and expected Cepher queries, basically, that are expected to come out of that. So it's very readable, just ASCII doc, and in our tests we basically pass this ASCII doc and verify that each of these GraphQL queries returns these Cepher queries and these parameters as such. So that's just a little bit about the background. And what I wanted to do is to see if we can, because we basically, now that we have all the middleware stuff in JavaScript and Java, our original thought was to kind of just decommission the extension, as it says here, just to decommission the extension. But we had a lot of users and customers that are still using it and wanted to have an update for the extension. So what we did is, or what I started to do, is basically taking the translator, which was the original goal anyway, to basically replace the implementation in the plugin with the translator, actually, so that the database extension would be just a very, very thin wrapper around the translator. Let me just minimize OBS here. I can quickly show you how this works. So I have an 4.1 database here with Neo4j Desktop. So it's Neo4j 4.1, and I created a movies database. So in Neo4j 4 we also need to support multi-database, so that's also something that we want to do. Here we have a movie database, and what I then did, I just built what I had so far in the project, and I just added the Neo4j GraphQL 4 and Epoch JAWS to the plugins folder, and I had to add, of course, the REST API mapping here, or the HTTP API mapping. It's not the REST API, the HTTP API mapping to this. And so I basically make this available, and so that we, for instance, can take graphical and use that. So the important thing is that you have to add a header with the basic auth to this. So this is just username and password as base64 encoded. So graphical can talk to our Neo4j database. And the other thing is, let me just simplify this real quick. So what we can do is we can post the schema to the IDL endpoint. So if I just run this, then it just posts the schema to the IDL endpoint, stores it in the database, so that when I now run a query like this, I can get my results back, right? So it will generate a Cepher query and then uses, for instance, here filters. We could also say like first two or something like that, or also order by, and then released descending. Let me make this a little bit bigger. Release descending, and then it should order the other way around, right? So you see that it also works. If I use here MA, I get matrix, for instance. And you can see that the release date is wrong of matrix revolutions. So that's really good. You can also use more complicated schemas. So like the one that I had here before, we have movie and person. And then actors is in field in movie that returns a list of people, and they have an acted in relationship in Neo4j with the direction in, as we can see here in Neo4j browser. Let me just do style reset. So we have our actors in orange here, and they have an acted in relationship to movies which is then represented by this here, by this relation directive. So we could also say we also want to see for these people the movies that they acted in, which is then a list of movie, and relation would be again acted in, and direction would be out, which is optional in the Java library. So if we post the schema, then, by the way, we should also see the docs here. So we see our top level queries, and then we also see our entities in here in the schema as well. Right, you can navigate also the schema. So it was correctly pushed, and now we can also use these relationships, for instance. So we see also like the people, and if I also want to see, for instance, other movies that the person acted in, for instance, we just use the movie title. Then we should, for each actor, we see the list of movie titles that they acted in as well. So that's kind of what we got so far. And I just want to show you how I built this. So also you can see that the database name is now in the URL. So it extracts the database name in the URL. So for instance, if I would create a new database, let's see, create database people, and then use people, create person name Alice. So now I have a database called people, and if I can also switch to that database, I should see here a single person with name Alice. And if I change this in graphical and just say we want to post this schema also to people database, GraphQL people property name database. Oh, I think we found a bug. See, good. Good job. So that's something that we need to fix then. So currently there's no people, or there are 2 people nodes there, which should not be there. Anyway, so we should be able to use this movies. So, oops. Movies. Cool. So this still works. So that's the setup and how it works. And now let's look at the code, which is fortunately not so much. So I was able to delete a lot of the code that originally was there. So I try to clean out all the things that are not really needed from the plugin anymore. And what's mostly left to do is kind of to fix the tests here. So let's see, what do we have? We have a REST resource that it's very old originally, and it gets passed in a log provider and a database management service. So the database management service is new, and then I have 2 main methods, a get and a post method for the queries. So you can pass here the database name as a path parameter in both, as you can see here. By the way, this is all Kotlin, so if you're not familiar, it looks a little bit funny if you're used to Java, but it still works. I also have to put in options so that course works as well. Okay. If you look at the simple one, which is or actually they are equally simple. The get method puts in the query and the parameters as query parameters, and the post one uses an pseudo JSON body. So we just in the get version we just generate this body as a map. Okay, and now we use the library. So that means for the actual work, we take the query, the GraphQL query that we got, extract the parameters. So the parameters is a little bit weird because the parameters is in from GraphQL, it's an JSON object encoded as a string, which is really weird, but that's the way it is. So we handle here both versions. So either when it's a string, then we just parse it into a map using Jackson, and if it's a map, then we just return it as a map. And otherwise, we use an empty map for the variables. And parse map just handles the blank case, because sometimes you also get null or blank or null even as a string in there. And otherwise, we just get a bit of excess white space removed and then parse the data as a map. So that's kind of just graphical particularity. So we have a query and the parameters, and then we get the database from our DBMS and just run our transactions. We begin a transaction and we have to do two things. So first of all, you have to get a schema, which I'll talk about in a minute, which is just as the IDL string. So it's currently not cached as such anywhere, the schema object. That's something that we could do in the future, or that we used to do in the past, but currently I'm just reading it time and again. And so we create a schema config, we just go with the default config. So all write and read mutations are currently generated. That's probably something that we want to move from being just parameters here to being directives on the schema. And then we build the schema out of this IDL string and the schema config. And then there's one extra case, which is introspection queries. So if you know GraphQL, then you know that let's see, in GraphQL org, if you look at the spec, or perhaps it's in learn as well. Introspection. So GraphQL is kind of self-reflective, so you can use GraphQL to introspect GraphQL. So you can run a query like this one, schema against the endpoint, and then it returns you what is in the in the schema, right? So if I run this, I should see these are all the types. So you see the official types, but also our types like movie and person, and you see also directives and stuff like that. So I think the types also have an let's see, of type kind. So it's nicely, so those default types, scalar types have no type. Oh no, there's also none. It's weird. Interesting. But at least it's self-introspectory, and that's also used to generate these docs as well. So if I look at this and look at the docs, this has been generated by the introspection query as such. And also the type completion and docs and help here is also all from the introspection query. So that's kind of our special case here, where we look if there's a schema query in there, then we just use GraphQL Java to take the schema and run the query against our schema and just ignore the rest basically. So we just get the data, any errors and extensions we just return directly. And otherwise, if it's a proper graphical query against our schema, then we do what we saw in the example. We just take the translator with the schema object and translate our graphical query plus the variables that have been passed in, and the query context, which is currently also just the default. So it has options like query type of interfaces, optimized queries, and stuff like that. And then we get back a combo of cipher and parameters, a list of cipher and parameters. So because you can have multiple queries in a single query. So for instance, if I simplify this here a little bit, let me do that. If I have, let's say, a query movie first to name, title. That's our first query. So we can also give it an alias M1, for instance. And this gives us like M1 as title here. And I see there's also a bug here. And then you should be able to do M2, which could be, for instance, the next two movies, right? So you could say offset 2. So these would be the next two movies, right? So this should be actually, the M2 should be the top level thing, not the other way around. So we found a second issue here. Okay. So that's why it's a list of cipher queries that you can get back. So it's for each of those top level aliases, you get one back. So we take each query and map we take each query and execute it against the database with the parameters that are also passed in here, generated here. And for the results, we just turn this into an list of results. So, and this is such a good question. So, and for the results, what we do is we take the first column, because we should only get one column back from the data, and then we take the column and map it to a sequence. So the question is, why is the type a list here? I think it should always be. Oh, it depends on the query itself. Okay, let's see. So, and then we can take the results here and get turn it. Sorry, the results, we get the first column, and then result has a method called column s, where we can pass in a column, and then we get an iterator, and we can turn this in Kotlin into a sequence. And if it's if the is list is set, then we just turn the sequence into a list, and otherwise we get just the first value or null if it's null. So, and what I'm a little bit confused by is these multiple column entries, right? So the column should be M1 here in our case, and we should have only one column M1 that is in data. So if you look at this, it should be like only one column N1, and then it should be a list of things. And I'm just curious what I did wrong here. So, so we probably need to write a test or debug this a little bit. So, and then after this is done, then we just commit the transaction from here, and then we do the next query, right? So each query should do one of these elements. So, and then we just map these results to the results. We don't handle errors except for catching the exception and adding them as an error. So you could also add a try catch around each of those and handle this here as well. And that's how far I got, and then it basically takes the result and formats it as a map. So you see that the actual use of Neo4j GraphQL Java is really minimal. It just generates the Cypher query and the parameters and the schema, and then the rest is just result translation. So we had two things that were weird, right? So one was the schema storage. Yeah. So the other thing that we need, if someone posts an IDL, a GraphQL schema to Neo4j, we need to store it somewhere, and I decided to just store it in a schema graph. That's why I wrote this class called schema storage. It takes in graph management service and database name, and then does the following. For updating a schema, it takes the database, begins the transaction, finds a single node with the label GraphQL schema and database, the database name as a property, and then creates the node here if it does not exist, and otherwise it sets the property name here as well. So it finds the node, if the node doesn't exist, it creates it, and then it sets the schema as a property here. After that, right? So it would overwrite a schema property that's here, and also sets a last updated property as well, and then commits the transaction. So the error that we got is that probably concurrently, because GraphiQL just tries to write the stuff concurrently, or pushes the stuff all the time, it created two of them. So we have two options. So first of all, we should probably create a constraint on startup on this one. So let's do this. So we just say create constraint. We don't need a database name, and we just say for this transaction schema constraints for this is our label. And we need a property. Assert property is unique database. Right. So we get our schema, create a constraint, and commit a transaction. And of course, you only need to do this if this schema does not exist. Can do schema constraint, get constraint by name. So, and we call it the same. And we call it this. And get this constraint, and we can probably also give it a name here, or name, if name. So this is our schema name. So we basically create this constraint here at the beginning. So, and actually I don't know what this returns. It's probably returns null, or can we download the sources also? So if this is okay, it's an exception. Okay, get constraints. If there's no such constraint, there's an exception. So I don't really like constraints. So let's turn this into a constant. So we can Control Alt. So we just turned it into a constant. And here. So, and then we can use constant here. So we just find all constraints and then a sequence filter it dot property keys contains and then property contains property, which we can also turn into a constant here. I don't know why the create constant refactoring doesn't work. That's really a little bit annoying. Property. So we find them, and then first or null. If empty, and if we don't find one, then we basically create this constraint here. Right, so don't need this name, and then what does it complain about? Sequence constraint definition. It's kind of pointless, right? So I thought if empty could also do okay. Filter. It's not so nice. So perhaps the try catches better. So catch constraint not found. So with name GraphQL unique. So, and then here we just say tx schema get constraint by name and use the same name here. Okay. Also not nice. What did it return again? An eager argument. So this allows us now to create our constraint at the beginning. So that also means that this gets much more involved. So we have a kernel extension, and the kernel extension on start should let's see, register an availability listener. And database event listener. And this has the database start, database shutdown. After start of the database panic. Actually, I want to have the availability listener. Where was this availability listener? I have to steal this from Epoch, I think. Epoch extension factory. So availability component lifecycle at resolver availability guard dependencies availability guard. Okay, so we need an availability guard here. So, and then we can say dependencies. Oops. this. And then we can use it here. Add listener and availability listener. This is just an lambda. No. So and so override fun available would create a constraint here if it doesn't exist yet, right? Schema storage, create constraint, and we pass in the DBMS. So database management service. So how did this work with interfaces? I completely forgot how this worked with interfaces in Kotlin. It's been a while. So we can just Google it, of course. Right. Here, Kotlin implement interface. Anonymous. Okay, object handler. Okay. So that's first the syntax, right? Object, this, and then override fun. So probably also need to override the other one. So, is there any way to simplify this? Can I inline this? Okay. So, okay, we learned something. How to do interfaces in Kotlin, probably. Implement interfaces. So we just create our constraint here, and then it basically takes care of that. Right, so... And we could probably do the name here also as a constant. Cool. I guess that's something that I'm gonna do anyway, is kind of to do all these things into constants. So this should at least prevent these things from being duplicated. The question is now, when we we accidentally, so it's kind of weird because you need to do a merge here, right? So I wonder if we should actually just use a cipher statement here and make sure that we are using that as such. So what we could do here instead is just write a cipher statement that says merge G GraphQL schema on database is database set g.schema schema and last right. So and then we just pass in the map of DB name and so, and then we just close this sort so that we can use the schema to enforce this. So begin TX. So this is safer, so we don't have to recreate basically label and property. So we merge on database and then update the schema and the last updated timestamp. So, and it doesn't like my map of. Oh, sorry, wrong language. So, these are parameters. And then we finish it. Alright, so together with the schema, it creates this. So, and here I probably want to move this with name at the beginning. Oops, I can't move it on the beginning, so I'll move it on the end. So, question is, when on startup, do we really want to, if this fails, I think we don't want to break the startup, so we just catch exceptions here and log them. Log GraphQL kernel extension factory Java class adding GraphQL constraint. So we just block the arrow and still continue to start up. Okay. Super. So this should take care of this duplicate thing. And now the other thing that I need to fix is the is to use these multiple aliases. Really quick before we close, I also want to show you how we work with the IDL. Basically, if you send a request to a DB IDL, then it just checks if it's directly an IDL, then it just executes it. Otherwise, it treats it like a GraphQL query here, because then we can kind of use GraphiQL to send these as well, like we did here. And that's kind of nice for a user, that they can just put in their IDL into this and then send here the GraphiQL, use GraphiQL also to send an IDL, because GraphiQL actually does a really good job of formatting the IDL and allowing us to handle this here. Okay, so I'll continue with this, and hopefully in the next few days I can put out the first version of this into the wild, so people can test it out as well. So we currently don't check the schema, I think, so that if it fails, then we should definitely get an error. Actually, perhaps we already do this. So because I think if I did something like this, then it complains about this here, right? So it returns the error here. It just should be errors, not error singular. So, and this is our result here. Cool, and if it's okay, then we just return the schema as result. Can probably return it as data. Can we return it as data entity map of because our schema is good question. If we just return it as data, then we should be able to render it in GraphiQL as well. Let's see if this works. Then we have at least a schema string here as data. Perhaps you can prettify this a little bit more so that it's nicer. And if you send a delete to db-idl, then it will delete the IDL. And if you send a get, then you get the schema back. So if I just send a get request with curl or something like that, then I get the schema back. And that's it so far. I'll continue to work on this, and I think the biggest thing is kind of the error handling and then updating all the tests. So I got a bunch of tests already to run, but it's not all the things yet. So this is kind of still work in progress. If you have any comments, please let me know, and then I can see if we can if I can share this earlier. Actually, I should push it to a branch, I guess. It doesn't fully build because some of the tests are still broken, as you can see. But we're getting there kind of step by step. Okay, that's it from me for today. Hope you have a good day and talk soon. Bye.